So I'm imagining it's evening for you guys. Since this lab is due at 11:59, it's probably about 10 p.m. So good evening. This is, I believe, the third video in this pre-lab, and in this video we're going to be going over the objective function and the sets of constraints for our orange juice problem. So first let's start with our objective function, and the special part about this objective function that we haven't seen before is that it uses a double summation. So if we're looking at our orange juice abstract model formulation, we're going to be coding this objective function here. And we can see that it's a double summation over the products and the quality set. So we're going to focus on how to incorporate that when we are writing this in Pyomo. So here's our entire model. The code that we're going to be focusing on for this little bit are these three lines that are creating our objective function. Now, like objective functions and constraints in Pyomo, abstract models have two parts. The first part is the rule, and the second part is sort of using that rule in our objective function declaration. So what our rule does is it basically provides the expression on how to calculate our objective function. And it's a Python function. And then our objective function declaration basically says, hey, when you're making my objective function, use this rule over here to make the expression. So our first part, when we're making our rule, we're basically going to write a Python function, and the only job of this Python function is to return this objective function expression that we see in the red box. So here he is. So let's go over the parts of these lines of code. So this is a Python function. So to create a Python function, you have to start with the keyword def. It means define. Then we have to give our function a name. And since this is a rule, it's sort of customary to use _rule in the name so that you can keep track of which functions in your code are related to rules and which functions are maybe actually functions that you're using for something else. And then the very first argument that we pass every single one of our rules is always a model. So in this case we're passing the model, and we can see that model argument being used many, many times in the return statement of this function. And then finally, when we're ready to start our function, when we're passed it all the arguments that we need, we end that sort of first line of a function with a colon. The colon basically says, hey, execute every single line that follows as long as it's indented. So we see the very first part of this function says return. That basically says the only thing this function is doing is giving you something back. It's returning you whatever follows on this line. There's nothing else that happens. And what it's returning is this expression we see here. So we see our expression up in our formulation line, and this big red box after the return statement is basically equivalent to that expression that we see in our formulation. So we're going to take a closer look at how these two things line up. So in our formulation, we see that we have two summation signs. We also see that we have an expression for what we are summing. And then we have these ranges of our subscripts. So we're going to see these same three parts in our Python code as well. So here in our formulation we see summation signs. In our Python code we see the word sum instead of these fancy Greek symbols. So we use the word sum, and we only need to write sum once. So even though we have two summation signs, we don't use two summation signs in Python. We just have one summation function, and we write the word sum. So if there were 17 summation signs in a row up in our formulation, we'd still only write the word sum one time. In our formulation we have our sort of blue box, which is our expression, which matches our blue box down in our Python code, which is the expression that we're summing over. And then the last part that matches is these ranges. And we see those ranges come after our expression, where we're saying for I in model.qualities and for j in model.products. So let's look a little closer at things now. We have our summation signs. We're going to write the word sum a single time. We have our expression. Our expression appears inside our sum function. And part of our expression uses our decision variable x, sub I, j, and we see that model.x and then in square brackets I comma j. So if we have two subscripts, we still use our square brackets, but we separate each of the subscripts by a comma. And then we have the ranges on our summation. So those ranges appear inside the sum function, but after the expression. And here we see that each of our ranges is just separated by spaces. So we basically say for I in model.qualities and then immediately go into for j in model.products. And then we'll see here that in our summations and our formulation, we can read it like j in products, I in qualities. So products came first, then qualities. But we see in our Python code that it says for I in model.qualities, for j in model.products, so the order is reversed. The order doesn't matter at all. So you could put these in any order. But what does matter is that the I that we're using in our decision variable matches with what that decision variable is expecting. So what does matter is that the placeholder variables are given the ranges that they expect to see. So for example, here our first subscript for model.x is I, and we're making sure we pass it a qualities because that's what it's expecting. And how do we know that that's what it's expecting? If we bring back our decision variables, so here they are, this is where we defined our decision variables. The very first subscript we gave it was for model.qualities. So since I is the placeholder in the first subscript, we know that it has to go with something in the qualities set. And similarly, when we declared our decision variable, model.products was listed second, so that's going to be our second subscript. So this j down here in model.x I comma j, this j is the second subscript, so it has to go with the model.products set. So making sure that these placeholders line up with the sets that they're expecting, that's what's really important, not necessarily the order. So that's our rule for creating this objective function. And curiously, we are never going to write code that calls this function. But what we're going to do is provide the Pyomo objective function this rule, and it's going to call this rule in the background. So we've written our rule. Now we need to attach or use this rule or attach this rule to our model using the objective function. So that code looks something like this. So we're going to have our rule. This is what we just wrote. Now we're going to write this second line, which will basically make use of our rule to make our objective function. So looking more closely at this second line, we see that this first part, model.maxProfit, is essentially adding something to our model, and we've named it maxProfit. Next, we're going to make use of the objective function, and this is basically telling our model that this maxProfit object that we just added to it is an objective function. And then this rule argument, or rule parameter of the objective function, is provided the rule that it can use to make the objective function. And the rule name has to match the rule that we just made. So we called our rule maxProfit rule, so we see that we're using that same maxProfit rule name here. And then the last part of an objective function is to tell it the sense. So to tell it whether we want to maximize or minimize this objective rule that we just gave it. And here we want to maximize profit. So we just coded these lines here. Next up is going to be some of our constraints. So we have two main sets of constraints in this OJ-Juice abstract model. So let's first look at this first set of constraints, which is making sure that when we're adding all of our oranges to different products, that for any given quality we don't use more oranges than we have of that quality. So this constraint is these three lines here, so let's look more closely at what's going on. So again, just like objective functions, constraints are made of a rule, and what the rule's job is when it's given a value for one of the constraints parameters, it's going to follow the provided pattern and make you a constraint. So we basically have this function that when given a value for, let's say, I or j, it returns a whole entire constraint to you. And then we have a constraint function declaration, which basically is telling Pyomo, hey, I want you to use this rule and make a whole bunch of constraints for me. So our rule is basically going to capture this expression for our constraint. So when we call this, or when Pyomo calls this rule, it's going to return a value of this expression up here for a given value of I. So we're going to pass our rule a value of I, and it's going to return us a specific instance of this expression. All right, so here's our rule. Starts off like any Python function with the word def. Then we've given it a nice name, and we want to make sure that we remember that this is a rule, so we named it with underscore rule somewhere in the name. And as always, the very first thing we pass to any of our functions is a model. And we can see that model being used 3 times in this return statement. And then after we provided a model, we want to provide it a comma-separated list of arguments that are needed to make one instance of the constraint. And if we're not sure what we should pass here, the best place to look is after the for all in our original formulation. So in our original formulation, it says for all I that are elements of quality. So that kind of indicates we can't make a constraint unless we know the value of I. So I'm going to pass this constraint function a value for I. And we see that value of I being used twice in this constraint function. It's used as the subscript of x, and it's also used as the subscript of our parameter available sub I. And then once we've listed all of our arguments that this function needs, we end it with a semicolon, and that semicolon basically instructs Python to execute all of the lines that follow, as long as they're indented, execute those lines as part of this function. And what we see is only one line. So we're going to call this function don't exceed available rule. Actually, we're not going to call it, but Pyomo will call it. And when it calls it, all it's going to do is return a constraint for that given value of I. And we see here the different parts of our expression. We see our expression involves a summation, so we see the word sum. The only thing we're summing over is xi sub j, so we see model.xi sub j. And again, we're seeing the use of square brackets instead of subscripts. And then because we have 2 parameters, we separate our parameters in our subscripts by commas. So we see I, comma, j. being used there. And then still inside our sum function, we see the range for what we're summing over. So we're summing over all j that are elements of products. So in our sum function, we see the words for j in model.products. And then outside of our sum function, we see our less than or equal to sign, and then followed by our parameter model.available, and then I in square brackets. So even our parameters can have subscripts, and they use square brackets to represent subscripts. So we've got our rule. Now we need to attach or make use of that rule when we create our constraints. So our whole constraint code is made up of 2 lines that make our rule, or our pattern to follow when making constraints, and 1 more line that says, hey, I want you to add a set of constraints to my model. Use this rule to do it. So we call that second line our constraint function declaration. So if we look at that second line, the first part, model.don't exceed quality constraint, is basically adding something to our model, and we've named the thing that we're adding don't exceed quality constraint. Moving along, we see that we're using Pyomo's constraint function, and our constraint function is basically going to create us a set of constraints. The very first thing we pass a constraint function, if we know we want more than one constraint, is we pass the set that's going to be used to make all of our different constraints. So in this case, in our formulation, we have for all I that are elements of qualities. This tells us that we need to pass our qualities set to our constraint function. And then our constraint function needs to know what rule to call over and over and over again with these different qualities. So we're telling it to use the don't exceed available rule. And that name needs to match the name of the function that we just made. So this line here basically says, Pyomo, call this don't exceed available rule for every single one of the values in this qualities set. So if we were looking at our very original OJ juice problem where we had quality 6 and quality 9 oranges, what would happen in the background is that Pyomo is going to call don't exceed available rule first for the quality 6 oranges, and it would create our quality 6 constraint. And then it's going to call it again in the background for our quality 9 oranges, and it's going to create our quality 9 constraint. And comparing our abstract model constraint code to our concrete model constraint code, we see that instead of writing out each one of our constraints for each of our different qualities as a separate line, our abstract constraint code is going to create all of those constraints for us. Whether we have 2 qualities or we have 17 different qualities, it's going to create all of them for us. We don't need to write them out separately anymore. So that was our first set of constraints, and now let's take a peek at this second set of constraints, the one that's making sure that we meet the required quality for each product. And that's these last 3 lines here. So again, our constraints are made up of a rule and a constraint function declaration. So our first part that we're going to be coding is our rule. So we're going to write a Python function that returns this expression that we've circled in red when we give a specific product j. So here it is, so let's see what's going on. As usual, we've started our Python function with the keyword def. We've named our rule using our nice rule naming convention where we've used underscore rule somewhere in the name. You don't need to, but this just makes it easier when you're going back and looking at your code, or maybe you have other functions that you're using. It kind of identifies this function as one of our rules that we're going to be using in our constraints. The very first thing, we always pass any of our rules as a model. We can see our model being used 3 times in this constraint. And then after we pass it a model, we have a comma-separated list of other arguments that we need in order to be able to make a constraint. So in this case, if we weren't really sure what to put here, if we have a for all after our constraint, so here we have for all j that are elements of products, this for all portion of our formulation tells us that we need to be passing something to this function. And in particular here we don't know j. So if we pass a specific value of j, we can make a constraint. So if we pass a specific product, let's say bags, we can make a constraint for bags. And then we see that j value being used twice within our constraint. And then finally, after our comma-separated list of arguments, and so far we've only seen examples with one argument, but we could have constraints where we're passing both an I and a j value. After our list of arguments, we have a colon, which says, all right, execute all the lines that are indented after this colon. But the only thing that this function is going to do is return a constraint expression when it's given a specific product j. And looking at this constraint expression, it starts with a summation up in our formulation, so we see the word sum in our Python code. Then we see our whole entire expression there that we're summing, so we see that expression also replicated down in our Python code. Our summation has a range, so we also see that show up in our Python code for I and model.qualities, and that's inside the summation function. So we see the range of our summation there. Looking a little bit more closely at that expression, we see it uses a value of I, and since we know our i's are qualities, they're all numbers, we can use those numbers right in our code, right in our mathematical expressions. We see required quality sub j. Again, we see model.required quality and then in square brackets j. And then we see xij, that's model.xij. And again, we have 2 subscripts, so we have square brackets, and then our subscripts are separated by commas. And then we see our greater than or equal to 0. Now it's important to note that that greater than or equal to 0 lives outside of the summation function. So our sum function has our expression and our range within its parentheses, but we don't want to try to sum over a greater than or equal to sign. It gets very angry about that. So we want to make sure that that greater than or equal to 0 lives outside the sum. Yeah, so that whole red part is in line with that circled Python code. And then what we see also in our constraint formulation up there is that for all j that are elements of products. So we also see that we've used that j in this rule as well. So the for all j, that tells us that we need to pass a value of j to our function. So we have our rule. The next part is to basically use our constraint function to make use of that rule. So we've got our rule, and then the next line that follows is basically a constraint function that makes use of that rule that we just made to make a bunch of constraints for us. Alright, so if we look more closely at this constraint function declaration, this first part, model.requiredQuality constraint, is basically saying, hey, add something to our model and call it requiredQuality constraint. And then we're using Pyomo's constraint function to tell our model that this model.requiredQuality constraint thing that we just named is a set of constraints. And this constraint function, if we know that we want to make more than one constraint, the very first thing we pass it is a set. And it's basically the set that we want to use in the rule that we're about to tell it about. So here I know that I want to make a constraint for every single one of my products, so I pass it the products set. And then I need to tell it what rule to call. So it's going to call the rule that I just made, the requiredQuality rule, and it's going to call it as many different times as the number of products in my products set. So for example, if we had our original OJ juice formulation with bags and juice, in the background, Pyomo is going to call a requiredQuality rule, and it's going to pass it a model, basically our model, and juice, and it will create our constraint that was related to juice. And then it's going to call that same function again, but the second time it's going to pass bags, and it will make in the background our constraint for bags. And if we had marmalade, and if we had maybe some other orange product, maybe orange gum, it would keep calling this constraint for every single one of our products, and it would keep adding more and more constraints to our model. And comparing our abstract code to our concrete code, we have one rule and then a constraint function that says call this rule over and over for all of our products. Our concrete model, we had to write all of the constraints out by hand. So our model didn't really grow very well. So that was our last part of this model. So now we've formulated everything. Our next video is going to go over how to add the lines of code to run this model, and then we'll see how nicely this model scales as we add products or add different qualities, how easy it is to use an abstract model.